Hello everybody, my name is Pamela and today I'll be doing mechanical technology automotive based on forces. So firstly I would like to define some few components of forces. So we have a tension force, a tensile force which is also called a tension. We have a compressive force which can also be called a compression. We have a shear force. A tension force can be defined as a pulling force that tries to elongate a material. Let's make an example. A cable supporting a hanging object. Then you have a comprehensive force. A comprehensive is a pushing force that tries to shorten or compress a material. Perfect example for a compressive force is a column under a building structure. Excuse me. Then we have a shear force. A shear force. Okay, let's define a shear force first. A shear force, a force that causes parts of material to slide past each other in opposite directions. Let's define example for it's like bolts under a cutting or a sliding action. Okay, now we're done with those concepts. Let's look at moment. Let's define moment for our one. A moment, can define it is a tendency of an object, of a force, not object, of a force to rotate, an object about a point or axis. Okay, now moment is the tendency of a force to an object. Is the tendency of a force to rotate. Sorry. How did I forget? To rotate. To rotate an object about a point or axis. Some people define it as it is a rotational equivalent of force in simple words. Okay, moment. We have a formula in moment, which is we're gonna be doing some few calculations just to help you guys understand, to help everybody understand. Okay, we have F times a D. This is the formula for moment. M is a moment, obviously, and F is a force that is applied. Then D is a perpendicular distance from the pivot of axis to the line of action of the force. Let me repeat. D is a perpendicular force, in simple words. Let's say it's A. Yes, in simple words, is a perpendicular force from the pivot of our axis to the line of action of the force. Okay, let's have some few examples of moments. Okay, let's say A, 200 newtons force is applied perpendicular to a wrench that is 0.3 meters long. Okay, here's your question. Here, this is our question. So we have this example. So like, let's see how to calculate a moment here. Okay. This is a formula. So this is our formula. M equal to F times a D. Okay. We have the force, which is 200 times a distance that we have been given, 0.3. So that equals to 60. And yeah, and is the units for moment. Okay, see, it's easy to calculate moments, but let's look at another examples in this case. Let's put this here. Okay, another example is a 100 Newton force is acts at an angle this time, an angle of 45 degrees. To a lever arm of 0.5 meters. Sorry. Okay. Sorry. Let's continue. Okay. Here, this time the force acts at an angle. So when a force acts at an angle, how do we calculate that? Well, there's going to be a slight change in our formula. It's going to be, instead of M is equal to F times a D. There's going to be a change in our formula. Here we're going to multiply again by a sine of theta. By a sine of theta. If the force is acting perpendicular, our formula is going to change and be like this. So it's going to act, so you're just gonna multiply by the sine of theta. So let's do that. Let's do that. We have M is equal to F times AD. So we have a force of 100 newtons, and we have let's call it S because we have an angle, and then multiply that angle by distance we have been given, which is 0.5 times times uh, the angle, which was been given, sine of 45 degrees. The answer we're gonna get is going to be, let's see, times 0.5 times sine of 45 degrees. I get 35,35, and yeah. So these are an example of moments, how we calculate moment, but these are just simple. So like, let's kick it up and see some tough examples. So I'm just gonna scroll down. I have a picture that I would like to share. Picture that has questions based on this. Okay, here we go. This is what we're gonna be calculating. I know it's a little blurry, but we're gonna try to work it out. Okay, like I said in the beginning, there are many definitions, so like, don't be scared when you see any definition. Okay, the first question says define a force. This is how you define. So we're gonna do a few examples calculating these questions here. Let me just zoom in and see what we're working with. Okay, 6.4. It says below shows a single force of 150 newtons acting sorry in a direction 35 north from west. Calculate the magnitude and the directions of the horizontal and vertical components. Okay, firstly, let's state the directions. Let's assume which direction I'm taking positive, which one I'm taking negative. So, okay, we have left and we have right. So, according to a Cartesian plane, when you go right, it's positive, and when you go left, it's negative. And there's also up and down. So, up is positive and down is negative. So let's take right as positive and left as negative. Okay, let's start with the calculations. We have been given a force that is acting at an angle of 35 degrees. We are calculating the component. So let's start with the vertical components. The vertical component is opposite to the angle, so it's going to be sine of theta. So is going to be sine of theta. Let's say x in this case. I'm not good at drawing this, so let me try. Sine of theta times by a force is equal to F vertical. And I'm not good at this. I don't know which one it is, but okay. Let's continue. Let's continue. Don't mind how I write. I'm not good at this. Don't mind how I write. Okay. So we have a sine, which is we have been given. It was sine. It was sine come on, let's go. You guys just keep all of this, don't worry. Okay, from here sine of x. We don't have a theta, so let's call it x is equal to times by a force equal to F vertical. So the force is 35 degrees times 150. The answer is equal to it's going to be 86,03. Okay, now that I've done calculating this one, you can also begin to calculate the parallel or the horizontal force. The horizontal force, we're gonna use cosine. Cosine, which is going to be fx is equal to cosine of x, the force. So we're gonna have cosine of 35 degrees multiplied by force of 150. We're gonna have 122. If I'm not wrong, yes, it is 122, comma 8, 8. So we have calculated what the vertical components, but we haven't answered the question. Is remember the question was, let's go back. The question was, calculate the magnitude and the direction of the horizontal and vertical components. We only calculated the magnitude. Now we need the directions. Okay, we said we're gonna take upward as we're gonna take upward as positive and downward as negative, right as positive and left as negative. So let's do that. So here, this one is going up, which is upward. That's the direction. So, okay, fx, which direction is fx going? It's going to the left, so it's going to be to the left. So right now we have finished answering your questions. You calculated the both magnitude and you found the directions of the vertical and the horizontal components. You have answered the question. Let's go to a next question. 6.5. 6.5. Let's take this down. We'll keep this so we can have all the information we need. If you're still these, you did this, you did this. So far that's what we have defined most things, and now we are in calculations. So okay, we are here. 6.5. 6.5. Let's see the question. A compressive force a compressive force of 30 kilonewtons is exerted onto a round bar with a diameter of 50 millimeter. Calculate the stress in material. Okay, before we calculate this question wants me to introduce one topic that I haven't talked about yet. So let's take the topic first, so then we do the calculation. So we have a stress. Stress, we have stress, which is a round bar and a square bar. Okay. When you're calculating a square bar, it doesn't take that much. You only have your formula. How to calculate stress. Stress, we have a formula for that. It is S is equal to F divided by A. Sorry for my writing bad, but here it's not S. We use this symbol. It's like this. So let's calculate some. So when you calculate, you need a force. You need a force and an area. So firstly, let's define what is a stress, so everybody can be clear before moving on. Okay, stress is defined as the force per unit area within materials. It quantifies how natural forces are distributed right over okay, this is how we define let's make it let's move it down here. Okay, this is how we define stress. Stress is defined as the source per unit area matters. It quantifies how mutual forces are distributed over a material cross section. Let's make an example of calculations of stress. Okay, I have this example. Let's say you are given a force of magnitude of magnitude 100 newtons, and we have S, which is 0.5 meters. We have been given this, and what you need to calculate your stress. So see, we have a force and we have S. S is sides of a square. This, when you calculate a square, you need a force and sides, and this S is squared. And when you calculate an area, is your S should be square equal to A. This is how you calculate your area. So let's calculate our area. We have S, which is 0.05, and squared. Sorry for that. Let's do it. It's going to be 0.025 if I'm not mistaken. Yes, it is. It's 0, so 0.025. Okay. This is the area of sides square in stress. Remember, I said we have two. We have a square bar and a round bar. You're still calculating if the case was squared. So you have your force 100 newtons and you have your area. So like you just put those in that formula, and you're gonna get your answer. It's 100 here over 0.025. So my laptop is slow, keep jamming, but I'll try to do my best. So okay, 0.002.5. Don't mind my handwriting. I don't know how to. Okay, there is a mistake here. Here, it's supposed to be. It's supposed to be 0.025. Okay, so the answer will be 400,000. You know what, let me just type it, because this still I can't have it now to write. The answer will be 400,000 here. But we can convert it by dividing by 1,000. It's giving us 400. Okay. Yeah. Hey. So this is how we calculate a stress in a square bar. Let me make it clear here. This a square bar. This is a square bar. Okay, let's go to round. Round is kind of simple too, but since it's round, so we're gonna have radius and pi. So this is how you write. So this is how you'll be writing your formula. Your formula is still the same, just that the areas. Now when you calculate the area, it's going to be pi, which is we don't have pi here. Pi times the radius. So this is how you calculate your area. Okay, let's say we have been, there's a case where we are given a force still the same mass, 1000. So no, sorry, what's happening here? Yeah, that is my mistake. Sorry guys, let me fix it. I just did it with my head like that. Yes, 40,000 PA, then and divided by 1000, it's 400. My mistake was here. Okay, let's continue. We have been given a force of 1000 newtons, and we have a diameter. Let's say it's 15 meters. The diameter is 15 meters, so that will make our radius 7.5. Yes, 7.5. The answer is so odd. Let me just write this because I'm messing up bad here. Okay. So our answer is still 0.0235, and so on. So like, let's just the answer is oh, 1, and so on. So like, this here is in PA, so like let's convert it in kilopascals, which is gonna divided by 1000. It's going to be 42. Now this is our example of what we were calculating. So let's calculate the real question now. Let's calculate the real question. So we are here, 6.5. A comprehensive force of 30 kN is exerted onto a round bar with a diameter of 50 millimeters. Calculate the stress in the material. Okay. First of all, we have been given. Let's write what we have been given. Given. We have a force of 30 kilonewtons and a diameter of 15 millimeters. That means our radius is the same, which is it's going to be 7,5, and radius, because it's a so it's going to be 7.5. Now this is how we calculate. Okay, let's begin with calculations. Here, we calculate stress. Stress is same, so like nothing has changed. It's still the same. So let's calculate our. We have our radius. We have our force. What more do we need? Okay, we just calculate. Yeah. So again, with our formula, our formula is 30,000 newtons. 30,000 newtons over area. Let's calculate the area. We need area. I don't know how to calculate the area. Let's just write it here. Pi times 0, 0, so just making this now. Okay, you get it. This is our radius, so you just like divide that. It's going to be 400,000. So you divide that with the 1000, gives you 4,000. So you have okay. We have calculated the stress in the material. Now let's move on to other question. Last question. This question says below below shows a uniform beam onto two perpendicular forces exerted. Calculate the total moment around point A by the forces around point A. So there's nothing new here, nothing new at all. So remember in the beginning we said moment is equal to F times D. So we have forces which is 190 and we have another which is 170. We have a distance which is 350 and 650 millimeters. So let's just write what we have been given. Okay, here it is. Here it is. So let's calculate. We have everything that we need. M is equal to 190 times 0.35. M is equal to 60.5. 66.5. This is our M. Now let's calculate from point A. This. So now let's calculate from this point. So here the distance from here to here is 350, and from here to here is 650. So we are calculating. So what we are calculating total around point A caused by the forces. So here from here is done, and from here to here, what is that? It's 1,000. Now we have our distance, we have our force. Let's just calculate. Now we have calculated our NM. So we have a thing that's called a clockwise and anti-clockwise. Let me explain. Clockwise is causing a rotation in this direction often. So like let's talk, when you talk about clockwise, is always negative. So like what I want, I'm just gonna skip this part. Then we have total So now we are done. We have calculated everything. We have calculated moment from 190 newtons to A and 170 to A, and we have calculated the total moment. So before I go, there's some key points that I would like to share with you when you're starting. Like in this topic, we talk about a spanner mostly. So like when you apply a force at the handle, the spanner is the nut of the ball around its axis. The distance from the center to the nut to where the force is applied is the moment arm. So the key points are: a longer spanner gives more moment for the same force. A higher moment helps in tightening or loosening a stubborn bolt. Thank you. Please like and follow. Thank you, everybody. Bye.